Alright, so this is Geometry Unit 7 Practice 3, and this is just a grind to help you get used to calculating sine, cosine, tangent, and using Pythagorean's theorem to figure out things that you don't know already. Okay, so um, just one thing to note is I went on here. You probably can't differentiate the two different colors, but this is burgundy and this is like a blue, and I've gone through and my y values, my up and down is burgundy, and my x values right and left is blue, and then my hypotenuse, my z value is orange, and then the opposite angle or corresponding angle with that line segment is the same color and the same value. I relabel it that way just to kind of help me power through these things. You don't have to do that. It's just a tactic that I use that helps me go through these things a little bit faster, and instead of just like arbitrarily labeling these things W, A, and K and stuff, I have a little bit more, you know, uh, reasonably and tactically labeled so that they make more sense to me, at least. All right, so how do we find, WK here? It is, not um, it's not, this one here is not there's, multiple ways to do this. But this is not the, what do you call it? The, the hypotenuse, right? So we can figure this one out by taking the square root of 36. So this would be, I guess I can write small enough here. I'm not going to change the color coding inside each one of these because it would just take all day to do that. So, in order to figure out y squared, oh man, I'm going to have to zoom in on this one. Maybe not. Y squared is going to be equal to z squared minus x squared. All right, so x squared here, or z squared, is 85. Let's take the square root of that. That's 9.21. This isn't going to come out. This isn't going to come out pretty this way, so I'm just going to. 36 is a perfect square, but 85 is not. So square root of 85 is not a perfect square. So I'm just going to do the square root of 85 minus 36. So 85 minus 36 is 49. Take the square root of that. Oh, that's 7. Okay, that worked out. Okay. All right, and we have these two here. So this is z, so we're going to square 20. And we're going to 21 square that, add them together, and we'll take the square root of that, and that's 29. Just go down the board using that same tactic. That's going to be the same thing, 29. They just swapped. Okay. Here, this is going to be, we have z and k here, or z and y, so this is going to be this squared minus this squared equals that. Right, so if you can remember this, maybe you can write it up here. Yeah, that'll help you if you can't remember the equation there. All right, so if I'm going to try to figure out this, I'm going to have to, if I'm going to try to figure out x, right, I'm just going to algebraically take y. I'm going to subtract. I'm going to take the square of this, take the square of that, or square that, subtract them. That's right. It's going to be 82 minus 51, and that'll be 31. Or I'm sorry, the square root of 31. Square root of 31. Because I have to square that. Okay. All right. So now let's go on to sine, cosine, and tangent for these, for all this side of this page here. All right, so the cosine is opposite over, this is over theta, or y is our or a here is our reference. So we're referencing this one. So cosine, we'll just do this one right here, these two y's here, okay, or our a's, opposite over hypotenuse, right? So opposite is 7 and 21 over 85 and 29. Okay, and then we'll do this, we'll shift to this one. Opposite is, now we're talking about x. Opposite is 20. Oops, 20. And the square root of 31 over 29 and the square root of 82. Okay, those are all of our cosines. All right, so hold on one second. Let me check something. I just caught a mistake I made. The very first one, of course, I'm still warming up. This should be square root of 36 squared. I forgot the squared. So this should be the square root of 85 squared minus 36 squared. And that ends up being 77 squared. 77. All right, so that ends up being 77 over 85. Okay. Oh, these are all, I wrote this in the wrong column. I was doing sine in the cosine column. And in the wrong color. That's all right. Can't tell the difference between those two there. Okay. All right. This is approximately 77 divided by 85, 0.906. 20 divided by 29 is approximately 0.690. This is 21 divided by 29, approximately 0.724. And this is 31 square root divided by 82 square root equals approximately 0.612. Okay. Whew. All right, now let's go ahead and do cosine. All right, cosine is adjacent over hypotenuse. All right, so we're talking about the y values here. So our adjacent is x. So it's going to be 36 over 36 and 20 over our hypotenuse, which is 85 and 29. All right, now shifting to x as our theta. Our adjacent is y, 21, and square root of 51, right, over our hypotenuse. They are the same. Square root of 82 and square root of, or in 29. And 29. All right. That's 36 divided by 85. That's approximately 0.424 21 divided by 29 is approximately 0.724. 20 divided by 29. 20 divided by 29 is approximately 0.6. Oh, 90. Hey, look at that. 690. I already did those two. Hey, isn't that interesting? Anyway, and then this is 51 square root divided by 82 square root equals 0.789. All right, almost done with the first page. Okay, now we're going to do tangent, which is opposite over adjacent. So we're not going to look at the z at all. I'm going to cover up the z. All right, and it's going to be opposite over adjacent, looking at y. Looking at y. All right, we can just do this. It's going to be opposite. Oh, okay, looking at y, it's opposite over adjacent. So it's going to be 77 over 36. And it's going to be 21 over 20. Oops. 21 over 20. Now we're going to look at x. X is going to be x opposite over adjacent, so it's going to be x over y, not y over x. All right, so it's going to be 20 over 21, and square root of 31 over square root of 51. Okay, so now more number crunching. All right, so we're going to do 77 divided by 36 is 2.14 approximately. 20 divided by 21 equals 0.952. I'm going to invert that for the next one, 1.05. And then I'm going to do 31 square root divided by 51 square root. It's going to be 7.14. All right. First page is done. Let's see what the next page looks like. I'm totally going to lose you if I try to. Okay. All right. I think you can see it. All right. Next page. We'll get this tomorrow. All right, so we got to do more Pythagorean's theorem here. All right, x squared plus y squared equals z squared, in case you forgot. Right, so z squared, so z 82, square root of 82 squared is 82. Minus a square root of 51 squared is 51 equals, take the square root of that, is approximately, so that I'm going to square that is the square root of 31. Yeah, this is, I already did that on the first page. Okay. And then we're going to do this one, which is, okay, so that's going to be, let's see, 17 squared times 16. Okay, so that was this squared. Okay, plus 20 squared equals, take the square root of that. Okay, so let me think. I'm going to square that. 17, 16, 42. Let me pause this for a second. Alright, so I worked that out to the 4 times the square root of 42. I'll show you how to do that if you want me to on another day, but I just don't want to burn up time on this one. Okay, so to figure out this one, it's going to be, it'll be 11 squared minus, let's see, 36 times 2 times 2. Hold on, it's going to be 11 squared is 121. 6 or square root of 2 squared is 2 times 36 equals 72. Okay, so 121 minus 72. The square root of that is 7. Okay. Alright, so that's all the Pythagorean theorem stuff done. Alright, so now we got to figure out, this one was cosine. I did the color coding right. This one was sine. And this one was tangent. Alright, so cosine first was adjacent over opposite, or adjacent over hypotenuse, which is x over, we have to look at our y value now. So y is going to be our x over z. So x over z is square root of 31 over square root of 82. And for this one, it's going to be square root 6 square root of 2 over 11. For this one, it'll be 20 over 4 square root of 42. Okay, and then for sines, it'll be the opposite. It'll be the y, 51 over square root of 82. This one will be 4 square root of 17 over 4 square root of 42. And this one will be 7 over 11. Okay, and now for tangent, for y, it'll be opposite over adjacent. Right, opposite over adjacent. So it'll be square root of 51 over square root of 31, 4 square root of 17 over 4 square root of 42. Wait, 4 square root of 17 over 20. Over 20. Over 20. And this will be 7 over 6 square root of 2. All right, so let's sort these ones out first before we move on to the next set or types. All right. So square root of 2 times 6 divided by 11 equals approximately 0.771. 7 or 20. I'm going to do 42 square root times 4 equals divided by 20 equals, I'm going to invert that, equals 0.772. 31 square root divided by 82 square root equals 0.612. Switch to burgundy. 51 square root divided by 82 square root equals approximately 0.789 for 17 square root times 4 divided by 42 square root times 4 equals, that gummed it all up because error of operations. Alright, so we'll have to do this a weird way. 17 square root times 4, and it's like 15. 42 square root divided by 4 equals divided by 15, and then invert that is approximately 9.25. I don't know about that. Okay. Divided by 4 divided by 42 square root. This is approximately 0.636. That's why I'll do that one. 7 divided by 11 equals approximately 0.636. Okay, now onto this one. 51 square root divided by 31 square root equals 5.57. Alright, so 4 times, we'll do 17 square root times 4 divided by 20 equals 0.824. Square root of 2 times 6 equals divided by 7. Invert that is 0.825. Alright. Now we're on to these ones. Alright, so this is x. Alright, so just with x we did 4 square root of 17 over 20. So this is going to be, this is the hypotenuse, right? So we're not going to be using that one. And then this, so here we go. This can help us that. So this is the hypotenuse. That's what tells us that. This is 85. It's the hypotenuse. And if this was the cosine, it tells us that 84 was the x value, and 13. Oh, wait a minute. No, this is x. It tells us that 13 this 84 was the x value. 84 was the x value, right? And then 13 was the, or was the y value, and 13 was the x value. Yeah, okay. Yeah, because cosine is x, sine is y. Wait a minute. Cosine x. Let's take a look real quick. X value x. Opposite over hypotenuse. Opposite. That's cosine, yeah. Opposite over hypotenuse. Yep. Okay, that's right. Okay, and that means the tangent for for this one would be opposite 84 divided by 13 is adjacent over hypotenuse for x. Adjacent for the cosine of x is adjacent over hypotenuse. So it's going to be, yeah, that's right. Okay. So this will be 13 divided by 84 though. 13 divided by 84. 13 divided by 84. Okay, there we go. That's right. Okay, so this one, the y value is going to be 11. So this is going to be opposite and adjacent. Opposite over adjacent. So the y value is going to be here. For when this is y, this is correct. When this is x, this is fluffed. That's right. Okay. And the x value is going to be here. 8. Okay. So to figure out the z value, we got to figure out 8 squared plus 11 squared equals, take the square root of that, it's like 13.6. So that means the cosine is going to be cosine is going to be 11 over 13.6. This will be 8 over 13.6. And then we'll have, this again is 9 and 40. So this is going to be, unlike this one, it's going to be 40. It's going to be 9 and 40. So 9 and 40. And this will be 9 squared. 9 squared plus 40 squared equals, to the square root of that, it's 41. That's interesting. Okay, 41. So the cosine is going to be opposite over adjacent. So it's going to be 40 divided by 41. 40 divided by 41. And then this will be, sine is going to be, cosine is going to be adjacent over hypotenuse. Sorry about that. And then the sine is going to be opposite over hypotenuse, which is going to be 9 divided by 41. Okay. Whew, that is a doozy. So lots of grinding there. Helps if you flip back and forth. Maybe make another triangle on this side to help you reference. But when it's all said and done, it's just going back and forth and understand Pythagoras theorem and sine, cosine, tangent. It can get confusing toward the end there, especially when you're fatigued. So if you get tired, take a break on that one. It's a long one. So just to get you exercise and practice and familiarity with sine, cosine, tangent, and Pythagoras theorem. Hope you guys have an understanding, and because you're going to need to know this stuff from this point forward. Otherwise, you're going to be lost and have a hard time. If you need more runtime on this stuff, please let me know, and I'll give you some more practice.